Imagine AI systems, not just assisting, but actually making decisions at the highest levels of a company. We're talking like board of directors level. Pretty wild, right? It raises a huge question, though. How do we make sure these incredibly powerful systems play by the rules, especially when, those rules were originally written for humans? Okay, so let's try and unpack this a bit. Today, we're taking a deep dive into this fascinating world where AI meets the law. Our mission really is to explore how we can create a clear, legal, and operational roadmap for truly autonomous AI systems. Specifically in corporate governance, we're leaning pretty heavily on a brilliant paper by A.S. Romanova called Fundamentals of Legislation for Autonomous Artificial Intelligence Systems, which really breaks down this new frontier. And for you listening, whether you're maybe navigating new tech at work or just really curious about what's next, this deep dive should give you a kind of shortcut to understanding one of the most pressing challenges in AI development today, making sure these systems are legal, ethical, and, well, safe.
It's a fascinating dilemma, isn't it? I mean, historically, laws are born from human experience, right? They're interpreted by human intuition, enforced by people. But as AI evolves, we're kind of heading towards a future where machines might enforce laws, maybe even make decisions based on them. And that really makes you wonder, can a legal system that's built for, human nuance and interpretation possibly work for an algorithm that needs absolute precision?
Yeah, that's the core tension right there. Romanova's paper really highlights this fundamental difference. The level of precision we accept from a human interpreting a rule is just vastly different from what an AI system seems to require. We humans are comfortable with a certain amount of ambiguity, reading between the lines. An AI, not so much.
And this isn't a completely new idea. It's kind of interesting. If you think back centuries, Leibniz, for example, he dreamed of a universal mathematics that could resolve all disputes with, pure mathematical precision. More recently, the mathematician Stephen Wolfram has talked about computational law, imagining a world where contracts could literally become explicit algorithms. He even suggested AI might need its own constitution. But the challenge, as he himself points out, is figuring out what should actually be in such a constitution. We're still sort of grappling with how to define that.
And here's where it gets particularly interesting and maybe a bit concerning, actually. We're seeing this really rapid rise of autonomous AI. Some systems are already being positioned to make decisions at the board level, yet kind of astonishingly, no country in the world has adopted or even really developed comprehensive legislation to regulate them. It feels like we're in completely uncharted territory. The tech is pushing boundaries way faster than our legal frameworks can keep up.
Yeah, and this isn't some, distant academic thought experiment. It's very real, and it's a present concern for everyone involved. You've got regulators, the developers creating these systems, the corporations deploying them, shareholders investing. They all want AI in corporate governance to be effective, but crucially, without introducing uncontrolled or, let's say, unreasonable risks. So crafting appropriate legislation, blending that deep legal theory with the very specific technical details of AI, it's absolutely vital for safe and ethical deployment, like right now. We need these guardrails, and we need them pretty quickly.
Okay, so if the big challenge is this gap between human-centric laws and AI's need for precision,
Yeah.
what's Romanova's solution for actually building those guardrails? The paper proposes this really brilliant analogy, borrowing a concept from the world of autonomous vehicles. They use the concept of an operational design domain, or ODD, if you come across that.
Oh, yeah, the ODD. It's a really crucial concept in the autonomous vehicle space. The SAE, that's the Society of Automotive Engineers, they're basically the leading authority for setting these kinds of benchmarks. They define an ODD as the combined operating conditions for which a given driving automation system is specifically designed to function. So it's not just drive anywhere. It's more like drive safely in these specific environments and conditions. And the British Standards Institution, the BSI, they further emphasize this. They state that defining an ODD isn't just a good idea, it's the very first step for safe autonomous vehicle use. It's all about ensuring informed safety by clearly communicating a system's capabilities and, just as importantly, its limitations. You simply have to know the operational context to guarantee performance and safety for these complex systems. It's fundamental.
That's a crucial distinction, isn't it? It almost sounds like we're accepting the limitations of AI up front, rather than trying to force it into a purely human mold. Like you said with self-driving cars, they can't literally obey all road rules made for humans. In fact, I think a European Commission report mentioned options like changing rules or even allowing AI to bypass them under specific defined conditions. So AI in corporate settings needs its own dedicated framework. It's not a one-to-one translation.
Exactly. And this idea of creating dedicated operational context isn't entirely new either. We actually have some, well, surprising parallels if you look around. Think about bilingual contracts, for instance. A joint venture agreement, say, in China might need both an English and a Chinese version. Why? To serve different operational contexts and legal requirements, making sure everything's clear for all parties involved. Or consider high-frequency trading systems in finance. They don't just operate under general market rules, do they? No, they have special regulatory techniques, specific disclosure rules, rigorous testing requirements, continuous monitoring systems. These are all examples of creating a dedicated, specific operational context, not for humans, but for the machines operating within them.
Those are fantastic points. It shows we've already been doing this in different ways. So bringing it back to autonomous corporate AI, the Romanova paper's core proposal, then, is to create this special operational context for them. How? By having local regulatory documents, things like corporate policies or codes of conduct, presented in two versions simultaneously. Is that right? One version for humans, as we understand them, and the other a machine-readable version specifically for the AI.
That's exactly it. And this approach gives the AI its clearly defined operational context. It allows it to perform its functions with the required quality and precision without ever having to try and interpret ambiguous human nuance. It's like giving the AI its own rule book written in a language it actually understands.
Right. And it kind of sidesteps those really messy philosophical debates about what safe or fair truly means by just defining it precisely within its operational domain.
Exactly. If we look at the G20 ECD principles of corporate governance, those are kind of our North Star for human boards, right? But trying to explain something abstract like acting in good faith to an algorithm, that's the core challenge. So Romanova's dual version documents, they aren't just a translation. They're more like a radical rethinking of how we codify these core ethics, transforming abstract human values into precise machine actionable directives. It's almost like building an ethical firmware for AI directors.
Okay, let's dive into how this might play out with some of those specific G20 OECD principles. First up, fair treatment of shareholders. This seems huge. The paper uses incidents like the Tesla Autopilot ones as a kind of warning. We need to move beyond engineers implicitly making ethical calls on behalf of users. For AI and corporate governance, shareholders need informed consent. That seems critical. So policies describing how the AI will behave, not just normally, but also in critical situations, they must be dual drafted, one for human understanding and one using AI-accessible metrics.
Absolutely. And that need for fair treatment extends directly to non-discrimination. Autonomous systems absolutely must avoid the discriminatory provision of services. That's clear. But here's a practical challenge. How do you even test an AI for bias? It's not simple. The paper suggests that corporate policies for these mixed boards with both human and AI directors must define specific, regular bias tests. They need to identify clear signs of both direct and indirect discrimination for the AI to follow and, crucially, report on. It's about building in those checks and balances right from the start.
Okay, so if we accept AI might face these really tough ethical dilemmas in critical moments, how do we guide it? How do we program that? The paper looks to what an EU expert group suggested. Rather than trying to micromanage every single decision, maybe we need to program for an ethical outcome through a continuous statistical distribution of risk. Does that make sense? It's about designing the system to inherently lean towards overall safety and equality, even when it can't foresee every single variable. For instance, you could program in abstract values, maybe like the relationship between vehicle speed and harm severity, to guide its decision-making calculus.
That's a powerful way to think about it, yeah. And these kinds of algorithmic approaches aren't entirely new in other fields either. Think about the really difficult ethical considerations involved in allocating scarce medical resources. Algorithms for things like equal treatment, worst-case preference, maximizing benefits, or rewarding social utility, they already exist. So for AI on corporate boards, policies would need to transparently disclose the specific criteria and metrics used for these risk distribution algorithms. Disclosure to both shareholders and other stakeholders. Transparency here is, well, absolutely paramount.
Okay, moving to the next principle, number 2. Monitoring management performance. This sounds like an area where AI's capabilities could really shine, doesn't it? The paper highlights how AI systems could actually be tasked with assessing the performance of human managers. Wow, imagine the implications of that.
It definitely brings to mind the concept of continuous audit and continuous reporting. That actually emerged back in the early 90s, mainly for auditing large digital databases. An AI isn't limited by human capacity or, a 9-to-5 workday. It can continuously monitor transactions, events, information, all in real time. So for corporate governance, policies for these AI directors must specify the exact activities, the data sources it needs, and the precise values the AI will continuously monitor for performance evaluation. It represents a real shift from, say, periodic reviews to potentially constant objective oversight.
Next up, Principle 3. Ensuring compliance with legislation. We know boards, based on the G20 OECD principles, oversee risk management and compliance with all applicable laws. This seems like another area where AI could be incredibly powerful, providing continuous monitoring of regulatory risks across loads of areas simultaneously: anti-bribery, anti-money laundering, financial services regs, assessing partner risk, M&A risks, even country-specific risks.
Yeah, the scope is huge. And this raises a crucial question. How does the AI actually get all this up-to-date information? It needs to be current. Romanova's paper emphasizes consolidating data from a really wide range of global sources. This could include things like leading data aggregators, media screening for reputational risk, court reviews, corporate structure information, third-party ownership details. A lot. So the policies for AI directors have to explicitly list these specific data sources and, critically, their update schedules. This ensures the AI is always working with the most current information available. Can't have it making decisions on old data.
Principle 4 is all about considering third-party interests. Boards are expected to consider and treat fairly the interests of all stakeholders: employees, creditors, customers, suppliers, the communities they operate in. The EU Commission, for example, suggested that autonomous systems should actually adapt their behavior to less protected road users, rather than expecting those users to adapt to the autonomous system.
That's an interesting point. It's a vital distinction, I think. For AI on boards, the paper suggests this translates into including special parameters and specific weights in the risk algorithms, specifically for those less protected users or stakeholders. For instance, ensuring employee well-being has a certain defined weighting in strategic decisions. These policies would need to clearly define what those parameters are and exactly how they're weighted, ensuring that the AI actively champions the interests of potentially more vulnerable groups.
Then we have Principle 5, informedness, good faith, due diligence, and care. Okay, for human directors, this means acting with full information, in good faith, with due diligence and care. Standard stuff, really. But for an AI, how do you translate that? It sounds like it becomes a formalized list of required sources, the specific data volume it needs to process, and the regularity of updates for its data, its algorithms, its models.
Exactly. Think continuous informedness, but taken to a whole new level, really. And AI isn't limited by human capacity or memory, right? It can check every single transaction, or specific ones, in real time or at set, frequent intervals, whatever is defined. So policies for AI must clearly outline the exact information sources it will draw from, the frequency of those updates, and the catalog of necessary activities it performs to maintain this, well, unparalleled state of being informed. It's arguably a much higher bar than for humans, but it's potentially achievable for an algorithm.
Principle 6 really gets into the nitty-gritty: the appointment and evaluation of an AI director. This is fascinating. When we appoint human directors, we look for knowledge, competence, experience. Like Saudi Arabia's code specifies academic qualifications and professional skills. Pretty standard. But for an AI, how on earth do you qualify it? It's not like kicking for a PhD or 20 years of industry experience, is it?
That really is the million-dollar question Romanova's paper grapples with. What are the right parameters? What kind of tests or exams should an AI pass to demonstrate it's fit for a board role? Especially given all the concerns we've seen floating around, like banks banning ChatGPT for business use, citing inaccuracies and legislative problems. You can't just, plug and play any AI off the shelf. It needs a rigorous, quantifiable selection process.
Right. And then how do you even evaluate its performance on an ongoing basis? For humans, it's regular assessments, maybe training. But for AI, it's not about sending it to a seminar, is it? It's about regular updates of its underlying data and its algorithms. So policies need to define how often, to what extent, and from what sources these updates happen to ensure its continued competence and relevance.
And finally, we come to Principle 7. Effective collaboration between humans and AI. This is where things get truly interesting, perhaps even strange. Entirely new communication methods will need to be developed for these mixed boards. I mean, think about it. Humans work, 9 to 5 generally? AI, as we know, can work 24/7. This fundamental difference in operational rhythms and capabilities demands entirely new interaction protocols. It's a whole new dynamic.
Absolutely. The very idea of business meetings as we know them completely changes. AI will likely use digital interfaces, maybe chatbots, visual holograms, or even VR, to communicate and present complex information. This is a whole new frontier for collaboration, requiring both humans and machines to adapt to entirely new ways of interacting and ultimately making complex decisions together. So, okay, to sum it all up then, the paper by A.S. Romanova makes a really compelling case. Autonomous AI systems need their own dedicated operational context, something distinct from our traditional human-centric legal frameworks. And we can learn from fields like autonomous vehicles and high-frequency trading, specifically by creating these dual-version regulatory documents, one for humans, one for the AI itself. This seems to offer a pragmatic and powerful path forward for integrating AI safely and effectively into corporate governance.
Yeah, and stepping back for just a moment, the paper gives us this really powerful analogy for thinking about this dedicated infrastructure. Autonomous AI isn't like a car on a general highway just trying to navigate rules meant for human drivers. It's actually more like a train or an airplane. Think about it. Despite their immense power and speed, trains and planes are statistically much safer than cars. Why? Because they operate within a dedicated infrastructure, tracks, airports, air corridors, very controlled environments. For AI and corporate governance, this dedicated infrastructure will largely be built through these specialized internal regulatory acts and those dual-version documents we've been discussing. It's all about building custom, precisely engineered rails for these powerful new systems to run on.
That's a great way to put it. This deep dive into Romanova's work really highlights that the future of AI isn't just about fancier algorithms, is it? It's also about the thoughtful creation of the legal and ethical rails it runs on. And it leaves us with a truly provocative thought to ponder. As AI becomes more sophisticated and these precise, machine-readable laws are developed for them, could these AI-specific rules eventually become the gold standard? Might they even influence how humans prefer to have their rules written? Seeking that same clarity and precision, even if it means dealing with a huge volume of data. What stands out to you as the biggest implication here as we wrap up?